Hey, Chan Physics. Not sure how many of you guys will actually watch this, but there's a key posted for this worksheet, electric power. I just wanted to go over a couple of the questions and then I'll fly through the key instead of actually doing the work here. But there's going to be two questions that I'm going to do live here. So the first thing is just, confirming that you took notes on what these things are. So here are all of the different I, R, V, and P. Work, we really didn't spend a lot of time. We did do work before. So work is W is work, that's in joules, or J. But I really wouldn't worry about that if you're the kind of person that's worried about something that might fall up on the test. I can't imagine work is going to show up on the test. Okay, so now I did tell you in the last video that you're going to need to learn how to at least convert from watts to kilowatts. And so I'm left this one blank. And so how do we convert? What we always do is we write down what we see or what's in the problem. So 350 watts, right? We immediately make a conversion factor. So we multiplication sign in a line. And whatever's here, we have to put down here. So we put watts here. And since they want to get to kilowatts, we're going to put K watts or kilowatts up there. And now all we need to do is what's a conversion factor? So like there are 12 inches in 1 foot, or so the idea is what is a kilowatt? And a kilowatt is like a kilometer. A kilometer has 1,000 miles on it. So same thing with a kilowatt. 1 kilowatt is 1,000 watts. Okay, so that's how we can think of that. A kilometer is 1,000 meters. A kilowatt is 1,000 watts. Okay, and so you see the watts divided by watts. Well, anything divided by itself crosses out. So that's that. And we just get 350 times 1 divided by 1,000. And we put that in our calculator, we get 0.350 kilowatts, because that's the only thing that's left here is kW. Okay, so that's how we do that problem, and you might have to do that on the test. And so I wanted to make sure that you saw that live. All right, so now we're going to go back to the key. And as I told you guys in the video, the four-column method is just a fantastic method. If you look at the block students, they'll all go through this work. And so if you think it's worthless or not worth the time, it really is pretty good in grounding us and making sure that we do everything right. All right, this question right here is a tough question because this is just one of many examples. So if you, what would you value, what would a value of 7.2 kilowatts on your electric meter really mean? It means that we're using 7.2 kilowatts for 1 hour, but it could also mean we're using 3.6 kilowatts for 2 hours. So really a tough question, and I wouldn't worry about that. All right, so now the next four are really simple applications of what we call the four-column method. We simply write down what we see. We write down the equation, power equals I times V, and then we substitute and we solve. So these first two we're just solving because both numbers are in the right side. And the second one here, we have power and we have voltage, but we don't have current. And so we're going to have to solve for current, and we get those numbers right there. So that's that first page. And these problems we can fly through once we know the four-column method. If you don't know the four-column method, you can still fly through them because it's really something we've been doing all year. All right, so then the next one is the same idea. We've got a flashlight, 6 watts. It's drawing a current of 2 amps. They want to know the voltage. We write down P equals I times V. We find out the voltage is 3. So if we have 1.5 volt batteries, we put them in series. We need 2 of them to work out. Okay. Another example of watts to kilowatts. Boom, right there. Then we can use this equation that we saw on the 6th or 7th page of the presentation. Energy equals power times time, or energy equals 1 kilowatt times 8 hours. We get 8 hours, 8 kilowatt hours. And then how do we convert that to money? Well, 8 kilowatt hours, there's 15 cents for every 1 kilowatt hour. So 8 times 15, $1.20 to run that heater for 8 hours. Okay. And so the same thing in this question is going to be the same 3 things. Can you convert watts to kilowatts? Well, 300 divided by 1,000 is 0.3. Can you then convert that into energy, power times time? So 0.3 times 2, we get 0.6. And then can convert that 0.6 into money. And we just 0.6 kilowatt hours, just like a conversion factor. 15 cents for every 1 kilowatt hours. You see the kilowatt hours cross out. We get 0.6 times 0.15, and we get 0.09, okay, or 9 cents. All right, the next question, though, is really not all that easy. And even if you're not a block student, you can use this method that we've been using whenever we get to a problem. So 9 is like, I read 9, it says calculate the resistance of a blender if it has a power of 700 watts. There's one number in there. It's not an easy question, right? And I think I told you in the video that we should assume that voltage is equal to 120 volts, right? So that's what we're going to start with. And so you're still like, I don't know how to do this. I don't know what equation to use. I'm just at a loss. So what we always says is, all right, well, you can always start a problem in the 4-column method, writing down what you know. So power equals 700 watts. Okay, the voltage is equal to 120, and we don't know what the current is, and they ask us to find the resistance. Okay, so you see all these power volts, right? Well, we've been using the equation power equals I times V. Could that possibly help us? Well, let's keep going right now. So power is 700, right? We don't know what the current is, so we could probably solve for it times 120. Well, that could get me current. Well, is that helpful? Well, if I solve for current, I get I equals 5.83 amps. Okay. Well, there's always this a possibility. We've done it a couple times to you guys, where you have to solve for one thing and then use a different equation for another thing. So what's the other equation that we've been using in electricity? We've been using Ohm's law. V equals I times R. Well, that's probably a pretty nice little addition, because we know the voltage, we now know the current, and they asked us to find the resistance, right? And so if we do that, we get 120 equals 5.83 times R. I can solve for R, and so R is going to end up being 20.57 ohms. All right, so that's a trick that we've used many, many times for that, like accelerator, or that extends, or whatever you want to say, like the A plus type question. Can you just go through the effort of going through the one thing and then finding that thing and then using it again for another thing? Okay. The last question, real quick. We don't need to do this, and so I hopefully will give this information to your to your sub that you don't need this. But how do you do this, right? Well, this looks like a conversion. It just says use $185 and you how many kilowatt hours do you use in a month? So if I write down $185, right? That's like a unit dollars, right? And then if I convert that, so put dollars down here and put kilowatts hours right here, right? Kilowatt hours. Well, we've been telling you the whole time to assume, or in all the problems, that for every 1 kilowatt hour, we pay 0.15 or 15 cents. And so you can see the dollars cross out. They asked us to find how many kilowatt hours we used. And so whatever 185 is times 1 divided by 0.15, and I get 1233.33 kilowatt hours. Okay. And so that was the last problem on that little sheet there. All right, good luck to you guys. Always come ask me questions. Find me. I'm going to open up all my wins for you guys, and we'll get you guys up and make sure that everything is going well. Talk to you soon. Thanks for watching.